Welcome back, everyone, to the water stream. I'd like to introduce Dave Brewer. This presentation is so you have a main break, now what? An emergency repair from a manufacturer's viewpoint. So Dave Brewer has been involved with the waterworks industry since 1991 and has worked with manufacturers in the underground water and waste markets in Canada in capacities ranging from inside sales to general manager. At Utility Supply West Corp, he works with companies that include Smith Blair, H-Tech US Pipe, and Copperhead Utility Locating to serve the underground utility markets. These markets include public works, consulting, engineers, and contractors. In the past, he participated on AWWA standards committees, including AWWA C219 and C226, and served 2 terms as president of the Municipal Services Association. So thank you, Dave, and I'll turn it over to you.
Wonderful, thank you. Well, here we are again. I was here last year, and we're still in the same virtual conference, but USC is very happy to be participating and contributing to this, what I think is a very valuable conference, the EOCP Virtual Conference of 2021. So, this is nothing new what we're going to go over today. Most of the people I'm thinking that are involved in this presentation have been involved at some capacity of repairing a main break. Keeps guys like me in business. What we're going to cover today is how it looks from our side, from the manufacturer side, and some of the things that a utility should be thinking about to avoid certainly, make sure they get in there and do it right the first time. But more importantly, future headaches that come down the line if you don't do it right, which I've personally been involved with. So with that, we'll go. So here we go. Something that's been done many, many times. It's interesting. We're going to talk about this type of repair later on. But if you look at this right now, we've got a service saddle on a piece of PVC, and it's got a lateral split in it. Think about that. I'll come back to this later, but in any case, water is supposed to be inside the pipe, not outside. And this is very standard. Doesn't matter what part of North America, for that matter, the world, where you are. You're going to see something like that, a Band-Aid, go on it, repair a clamp, and you get you back on your feet. And eventually it's all sealed up, and we move on. I grabbed that picture because I thought it was interesting. You might have a problem with your piping, your corrosion, or you might have a problem with that entire area if you've got stainless steel clamps every so many inches on your pipe. So in any case, the repair clamp to the rescue, done every day in the utility. So a repair clamp is a device designed to make a simple repair to a water main. The repair clamp is constructed of 1 or 2, 3 sections. Sometimes the number of sections could be even greater for repairs of larger diameter pipe. The advantage of a repair clamp is that it allows for a quick temporary repair. I'm going to come back and touch on that temporary later. That reduces the loss of water service to water users. Not having to shut the water main down also reduces the possibility of contaminants entering the water system due to reduced pressures. So that's kind of a repair clamp in a nutshell. One thing that's not too widely known, even though the standard came out in 2011, this was repair clamps. I used to be with Robar. Robar was the first patent holder of the all stainless steel repair clamp, and that was back in the 60s. And it took up to 2011 for this repair clamp, the repair clamps to come down underneath a recognized standard by the AWWA. So that was established in 2011. The standard sets the requirements for the materials to be used in the construction of the repair clamps. These materials include stainless steel, meeting or exceeding ASTM C240, as well as all materials contacting potable water should meet the requirements of the Safe Water Drinking Act, NSF 61. So the minimum performance requirements of a repair clamp are as follows. The clamp shall be tested to a minimum pressure of 50 psi for a period of 24 hours. This is right out of the standard. For the proof of design, hydrostatic testing shall be 150% of the rated pressure of the clamp. So it's a very simple test. You basically could take a metallic pipe, or you could take a PVC pipe, or what have you, and you groove it to within 1/8 of an inch of a groove, and you have lines coming in and out of the pipe. So we're going to put water in one, and the air bleeds out of the other, then we shut it off. And this is replicating what? Like a shear or beam break. And then what we do is we just have to hold the pressures, as we stated before, 50 psi for 24 hours with a 1.5 times safety factor. That's it. So at the bare minimum, if you're putting a repair clamp in your utility, you want to make sure that they meet this standard. That's very important. And for the record, most of the manufacturers that I'm aware of in North America are capable of meeting this standard. For repairs in a utility, ensure that your repair clamps can meet this established standard. Not meeting this standard exposes the utility to a product of lesser quality and inferior performance. I only mention it because I have seen products that aren't even familiar with what AWWA is. And you could probably put it in the ground and you're fine, but when you're not, and it breaks, and you're flooding 3 neighbors' basements, someone's going to be asking questions. So it's a very simple thing to make sure that the manufacturer is self-governing their product to make sure they comply with that standard so your utility doesn't have to. Repair clamp installation may require a dewatering pump to remove some of the water in the hole before the attempt can be made to install the repair clamp. If the damaged pipe cannot be accessed due to the volume of water exiting the main, then it may be necessary to isolate the water main through a valve closure before the repair can be done. I have a video coming up that puts that statement to the test, so we'll see that in a bit. Of course, all affected water users in the area should be advised of the water break and pending interruption of the water supply due to any valve closures. When an emergency repair needs to be done, be sure to take all the proper safety precautions when going out to do the repair. Ensure all underground utilities are located before exposing the pipe. Things to remember about a repair clamp. Repair clamps have different types of closures, such as finger stud mesh. So this is this is Western Canada, say from Manitoba west. This is all you know. That's all you've ever seen. The funny thing is, this is probably a fraction of the repair clamps that are actually used in North America on an annual basis. The next one that is by far the most popular is what we see, and we don't see it in Western Canada at all, is called the ductile lug mesh. So this is a stainless steel band. Actually, the interesting thing about this is that clamp, because it's welded, we desensitize the stainless steel, and it needs to go through a chemical passivation to take all the impurities that come out of the stainless steel when we weld it. If you don't do that, then you're going to have stainless steel that's not worth anything, and it's going to rust. So it goes through a chemical passivation. Oops. This clamp here, because there's no welding done to it, the stainless steel is simply worked so it fits in a channel in the ductile and lug bar, and then you just tighten it down. So of course it's not all stainless, but you have a thick mass in that ductile and lug region that is typically epoxy or shop coated. Then of course the other part that's really important is the gasket. Actually, a lot of people overlook the value of what this is. It's a gasket. You just wrap it around and tighten it. There's actually a real purpose. You know, when I was at my previous company, Robar, I learned a lot about the repair clamps, and those squares actually they play a very vital role. Each square is essentially acting like a suction cup on that pipe. And so when we do use these, the use of a lubricant is very important. You have to use a lubricant because each one of those squares, when compressed, will act like a suction cup on the pipe that is going to aid in your sealing ability on the pipe. So you definitely want to have the ability to have lubrication and have those squares do what they're meant to do with you on the pipe for you. And this is just a blow-up of it. So, of course, different manufacturers are going to have different patterns, but more or less they're all going to be in a square pattern, much as like you see there. The last one is, depending on the size of the clamp, outlets could be supplied 3/4 through 2-inch in CC or IP threads. One thing I'm noticing in a lot of utilities, when they go to do AC, they got to run a service off AC pipe. I was with a local utility very recently that was, well, I'll say the local utility wanted to use something like this for AC pipe to take a service off, only because there's the fear that you could go into a beam break on the AC pipe. And if you go into a beam break, a service saddle is not going to work, whereas a repair clamp still has the ability to form that seal. You go into provinces like Saskatchewan, that's all they use for services on AC pipe, is this type of repair clamp with outlets. So it gives them an extra ounce of protection against such actions on AC pipe. Now we're just a matter of preference on a repair clamp. And I can remember years ago somebody would call up because typically somebody's cracked a pipe and they say, I need a repair clamp. And they go, you ask them what size. It's 6-inch. Well, okay, what style of clamp do you want? I don't care. Usually at this point they're in full panic mode. It's good to know ahead of time what you want to use. All of these will do the same thing, but then it becomes a matter of user preference as to what you want. This one here is called a style 1, and this is referring to one closure. It has one row of bolts, a single piece of a full wrap gasket. It has one armor on the gasket to protect the gasket from being pinched when doing up on the clamp. And traditionally, these clamps are available in nominal sizes 3 through 12-inch, coming with a 0.4 of an operating range. You can come, I've sold these things down to 1/2-inch tubing. So they come smaller than that. They don't offer a 0.4 of a range, but you can get them as small as a 1/2-inch. Second one is you have 2 rows of bolts. So if you go to places like, again, on the prairies, I'm going to assume most of the participants on this conference today are probably from British Columbia, but if you go to, if this was, let's say, Saskatchewan, this is the only style clamp they really use, and that's the 2 style. And again, that's a matter of preference, but you also get a wider range. So it's very similar to the first one we just looked at, except it's got 2 rows of bolts. It has two gaskets. You have a top and a bottom, and you have 2 armors. And then, of course, these are available 4 through 16-inch, and they come with 0.8 of a range. So the reason why they keep these is they just have probably a wider range of pipe, and they can keep a smaller amount of inventory. Of course, you're paying more money for the clamp, but you get a wider fit. And in some instances, it's certainly easier to install than a style 1. But we'll cover that in a bit. You get the idea. We just keep adding panels to it to go bigger and bigger. Of course, when you go bigger and bigger, I'll show some of the pitfalls. The larger the repair clamp goes, there are some limitations to it. But again, just like the first 2 we saw, except one row of bolts is generally reversed to make the installation easier. So we have 2. So what they'll do is instead of all the bolts facing in one direction, they'll have one row of bolts facing the opposite way. And if you look at the top of the picture on that repair clamp, you have 2 row of bolts facing the operator so that he would position those so that he's only having to go underneath and do 1 bolt up around the backside. And of course, because each time we add a section or panel to this, we go up 0.4 of a range. So with this particular style of clamp, you get 1.2 inch of range. So you're really covering a wide range of pipe. And generally, we can make these, I've seen these as small as 10 inches. You're going to see these 10-inch through 30, 36-inch pipe. So now that we know this, we got the different types of repairs and the things that we have to keep in mind as to what a clamp can actually do, all right? So there are many different types of repairs that a repair clamp can seal. Listed below are a few that, when installed correctly, can be sealed by a repair clamp. So the first one is like a full break, also known as a shear or beam break, normally associated with a pipe that has been subjected to excessive amounts of concentrated deflection or point loading. Asbestos cement pipe, old cast iron pipe are very susceptible to this form of break. Holes, pitting, ductile iron, any kind of metallic pipe, put in the bad soils without any kind of additional cathodic protection are going to rust over time. Can result from a section of pipe that is weakened and exposed to subjected pressure surge. Could be air in the line that pops a hole in there too. Another way for the hole to develop is from improper bedding and a direct point load on the pipe. So back in the day, I've been involved in pipe repair for over 30 years now. It's not uncommon some of the pipe that was put back in the day in the 70s and so forth, because it was so rough and robust, they'd leave big boulders in the trench and drop the pipe on top of it. And that's where your hole's going to develop eventually. Pulled service lines. A pipe that has a direct tap service torn or ripped during an adjacent construction being performed. Normally, a bucket operator inadvertently snags the service line. It happens. It's just Monday morning, not quite awake, and you snag a line and you rip it out. You wake up pretty quick after that, though. Pinholes, again, just corrosion in a set area. Cracker splits. Remember the first slide I showed to you in the presentation, cracker split, can typically develop in a couple of ways. The first is with a PVC pipe that has a grain structure that, when subjected to external internal stress, opens up and runs the length of the pipe So how it's typically opened up is if you have somebody running a lateral off of it, and it'll, the energies in the pipe will be released at that moment. It'll follow the grain structure of the pipe. The second is a metal pipe with a material thickness loss due to corrosive environments. Due to a corrosive environment is exposed to a pressure surge or sudden movement. So metallic pipes, just so we're equal here, they could be subjected to some really bad soils. And typically you're going to see that corrosion at the bottom of the pipe. And then you get a pressure surge, and the material thickness as such, the pipe just doesn't have the robustness anymore to hold it, and she pops, and she's typically blown out at the bottom. That's been my experience, at least. So you're going to get the crack or split. So this is a big one, and you take this for what it's worth, but I do want you to remember this, and is this a temporary or permanent repair? Because they have to be distinguished. Being involved in these situations, you better know when you need to go back in and address a situation that is going to further deteriorate, which could further disturb or disrupt my customer base, which is your water users. When choosing your type of repair to be done, there are a number of considerations for the utility to consider. Emergency repairs very seldom afford the utility luxury of having the time to thoroughly consider all the alternatives available to them. In other words, we've got to get the water leak stopped, and we got to get the water back on for the customer. That's a given. I understand that. You know, quite often they're faced with having to get the affected damage back into operation in the most expeditious way, while also making sure they are done so and with all safety considerations being met. But you need to understand, is this permanent or is this temporary? And quite honestly, most repair clamp should be considered temporary, because there's a problem with your pipe. Your piping structure has been compromised. Identifying that problem is going to address what's causing the failures. Putting a repair clamp on it just temporarily stops it. With all this to consider, it is important that a proper assessment is done to determine what type of repair is required to bring the affected main back online in the quickest timeline possible. So with the full break, when the two pipe ends have not moved any great deal or at all, the repair clamp is suited. It's perfect. It's ideal. You just basically wrap it around, put it together, and you're done. Though if doing so, the operator should try to go as wide as they can in the pipe to provide the reinforced area of the location of the break. So in other words, go as wide as you can when you're doing this. You don't want to go as narrow as you can. Chances are, if there's a beam break, that pipe on either side is going to want to shift or move. It's underground, it's buried, it's exposed to soils that are moving. Go as wide as you can, provide strength at that area. So one thing to keep in mind, because you're essentially using a repair clamp as a coupling, you're joining something that's been severed. So recommended gap when joining and repairing full breaks. For pipes, less than 4 inch, 1/16 of a pipe gap, okay? For pipe sizes 4 to 10, maximum gap would be a 1/4 inch. For pipe sizes 12 inch or greater, 1/2 inch max gap. If you're greater than this, when a gap between the pipe exceeds 1 inch, utilities utilize a short section of pipe or a thin strip of sheet metal wrapped around the pipe to properly support the gasket. So if you're in a pinch, you're in the utility, it's 3 in the morning, you don't have the luxury of finding something that you need, but you got a repair clamp, grab some sort of shim stock or something to wrap around the pipe. What we want to do is we want to be able to put where that armor plate is, that is where your leak path's going to be if you got a bigger gap than that. Right at that armor, because that gasket has a tail on it that blends into the other side of the shell. And if it doesn't have the proper compression on it, because you've got a big gap there, you're going to get a leak. So try to take that void out of the equation if at all possible. I don't care what you use, something that's safe for potable water, obviously, but some sort of tin, something metal that's going to take that up, or take a short, if somebody is good on the saw, and cut a short section of pipe, put it in there when you put the repair clamp on. Of course, that's not ideal. The most ideal way to do a repair like that would, when a gap is exceeded, the two pipe ends can show signs of misalignment from their former positions. For this reason, a repair clamp can be, and I've heard this a number of times, repair clamp can be difficult to assemble if the misalignment is too much for the clamp to bring back into line and form a seal. So in this particular instance, in these scenarios, we advise that to use a new suitable size spool piece, depending on the amount of realignment required, and 2 mechanical bolted couplings. That would be the ideal way. Again, it's not always available to you. And now what I've just kind of explained to you is what's available to you if you're in that situation to make a repair clamp work. And I have seen plenty of utility operators make stuff work. So it's well within the capabilities. But long term, this would be more ideal. Holes. So very typical of a very typical type of repair for a repair clamp. An important rule to keep in mind is to maintain 6 to 8 inches of clamp on either side of the repair. If the clamp being used is used to close off a large hole, or perhaps a location of a service, this happens quite often. Somebody's taking off a 4-inch lateral, a 6-inch lateral, and they want to put a repair clamp on it. Not ideal. Because you think about the clamp wrapping around there, and you got that big hole. There's nothing pushing back against against the gasket on the repair clamp. Advise they use a thin layer of stainless steel metal roll to the curvature of the pipe and placed over the hole before installing the clamp to provide additional strength to the area. Again, if we don't have the ability to compress the gasket there, you're probably going to have a leak path. In these instances, it's recommended to contact your manufacturer, whoever you use, and to advise to perhaps they are special considerations that need to be made before the proper clamp choice can be made. So, and we all know who those are throughout your various channels. Pulled service line or branch connection. This is straightforward repair for the operator. All that is need to know is whether they intend to maintain the location of the torn out service or not. If so, then the operator will need to install a clamp with a bossed outlet and incorporate it into it. Depending on the size of the hole that has been torn out, the consideration must be given to how wide the clamp needs to be made to make sure the 6 or 8 inches of gasket length is required. So we want 3 to 4 inches on either side. So something like this would easily replace where your torn service would typically be on a direct tap, or if you nicked a service out as well. Pinholes. This would appear to be straightforward repair for the operators. They see the water spraying from a small hole that would be sealed with the use of a repair clamp. Usually there will be some pitting and form of corrosion located at the leak. However, the operator should be considering the pipe material where the hole is developed. If a metal pipe, then he or she must consider what are the factors that cause the hole to develop. If the clamp is simply installed, the process that caused the pinhole has not been stopped. It's been simply bandaged, and the process will cause the pinholes will continue to be left if unchecked. In these scenarios, steps should be taken by the utility to make sure the repair is not doomed to future failure after backfill. I have personally been involved, unfortunately, in a couple of these instances. And both of them have not been very good, as you have a utility will have a distinct problem with the soils, and their pipe is deteriorating, and usually 3 or 4 repair clamps on the same line is a sign that there's something going on. Putting another repair clamp on is not going to stop the process. So the utility really needs to step back and take a look and see what's going on. Do we need the budget for this section of pipe to be removed? Simply putting the repair clamp on stops the water at that particular time. Not long term. And a future plan would be made to take that out, because if not, it could turn into a long, nasty process that nobody wants to go through. Cracker splits. In these instances, it may be difficult to use a repair clamp unless the operator is able to get the clamp width sufficiently covers the affected area. I mean, these things can run the whole length of the pipe. If you get fused, I'm not dumping on any particular pipe manufacturer, but I have known instances on fused PVC, for whatever reason, to develop a crack and to go for meters on end. So you're not going to be using a repair clamp on that. But if you got a split and able to get a clamp on it, in some instances the repair clamp can be modified or joined or linked, and I'll go into that later in the presentation, where you can modify your clamp to make a longer clamp. Again, as with the pinholes, if on a metallic pipe, what circumstances cause the pipe to fail in such a manner, that needs to be taken into consideration. Similar precautions should be taken to address the issues that causing the structure to be of the pipe to be weakened. If the operator is dealing with PVC repair and the split continues to migrate down the pipe, the simple fix is to stop this split is to drill a small hole at either end of the split to stop the crack. It's just simply following the grain of the pipe, and that'll stop it. That should be pretty well known for most utilities. So we've determined the break. Now the fun part. So this is just a quick video that I'm sure it's going to resonate with a lot of utility operators on this presentation right now. You're going to get wet that day. And for whatever reason, I mean, this is not ideal, not safe by any stretch, but it's a good indication of what you could face. And it's a great video showing how repair clamps being used. So they're going to break open the hole, and here they are. They've got the repair clamp. They've assembled it beside the pipe, and now they're sliding it over the hole, which has extraordinary pressure coming out of it right now. And essentially, he's going to slide that over. He's got to loosen off the bolts a little bit. And now he's got it, holding it in place. And here goes the Milwaukee. I think that's a Milwaukee. Boom, done. So, and the guy's 3 houses down the road, he doesn't even know what happened. So, utility workers truly are amazing. So, now we've got this identified. We know we've got the break. Of course, these are all, you know, we came to work, we want to go home from work that day. So, no matter what's going on, safety always comes first. So make sure you follow all the provincial and local codes, ordinances pertaining to the site-specific new construction and or repairs. Always wear the proper personnel protective equipment. Always read provided instructions. It's a joke in our industry because most of those go into the ditch, but I cannot emphasize it enough. Give it a quick read. Be familiar. You may have had a utility that was using brand A for 20 years, and all of a sudden you switched over to brand B. And there might be a simple change in the installation. You better know that. You better know that. Call local representatives, distributors, or manufacturers for any questions, concerns prior to installation. Most of you guys in the utilities are all handed out pie tapes so you can make sure you got the right OD, that you know exactly what it is. It might be old cast that's just outside typical repair clamps or AC pipe. Always should have a pie tape with you. Probably going to have your custom sockets on hand, the deep sockets, or you're going to have a zip wheel to cut off the bolts if you need to get at a long one. A marker, if it's dry, you want to mark where your clamp's going to go. Calibrated torque wrench. A lubricant. And obviously your personal protective equipment. In those trucks, you know, you should have a good tool as a resource is your OD chart. If you don't have an OD chart, call your local manufacturer or distributor. They'll get one for you. Most trucks I see or yards, they have the big OD chart sitting right beside the pipe repair tools. It's a great thing to become familiar with. So you want to select the clamp that has the OD range covering the pipe OD. Select the proper clamp width so that sufficient solid pipe is present on each side of the damaged area. There's no point getting the repair clamp out if your pipe's all gouged and damaged and pitted. It's not going to work. So for sizes less than 12 inch, you want to have 3 inches of solid pipe on either side. For sizes greater, 12 inch or greater, 4 inches of solid pipe on each side. And most manufacturers make incremental widths of 8, 12.5, 15, 20, 25, 30, and larger. And some of them make them just custom to what you need. So now we're going to install our clamp, and this will be just a simple walkthrough, and hopefully we can resonate with a couple points here to help your clamp installation go a little bit better. Obviously, clean your pipe. If you're like those guys in that video, you don't have to worry about it. You've pressure washed the pipe already, it's clean. But make sure you wash the pipe and measure it with a pie tape to make sure, if you're not familiar with the pipe, what it is that you're dealing with. Establish your lines with your marker where the repair clamp's going to go. Place the clamp around the pipe centered over the break or the damage with a gasket flap at the top. That gasket flap should be at the top. Now, again, for those of you who've put hundreds or thousands of these on, this is old hat, but if you're new to it, keep this in mind because you're going to be fighting that clamp otherwise, okay? So that flap is at the top, that gasket flap. The other thing is for optimum product performance, the fitting should be lubricated with suitable lubricant. For multi-band clamps, the gap between band is approximately 3/8 of an inch for pipe diameters near the bottom of the clamp OD range, and approximately 1 1/4 inch for pipe near the depth. So in other words, you're going to have some gap. So it's going to range from a 3-inch to a 1 1/4 inch between your finger section and your stud section. And lubricate the pipe. Tuck the flap in place and mesh the lug fingers by pulling the keeper bar upward. So the keeper bar is just underneath the nuts, and you're going to snap it over the finger weldment base and hand tighten. You have to get that gasket flap in there. If you don't have the gasket flap, stop, open it up. The gasket flap is tucked up underneath. Make sure you got that gasket flap out. You could also assemble the clamp beside the break or damaged area and slide into position. Pipe surface must be wet or lubricated in order for you to do so. And once you've got that done, now you're ready to tighten it up. Rotate the clamp away from the gasket taper flap to ensure the proper seating of the gasket position, the bolts and tights for convenient tightening. So what we're saying here is that you're going to roll that clamp away from you, and that if you don't have that flap perfectly seated against that pipe, when you roll it away from you, it is going to seat that flap. It will seat itself, and then you could just roll it around until you get it to the proper position for tightening. The torque values, these are typically what I work with, but always go with the manufacturer. Typically, the torque values are written right on the clamp itself. You want to, if you're doing, let's say, a 16-inch or 24-inch clamp, start from the inside and work your ways out, and work to the torque values they've suggested. When the nuts have been tightened sufficiently to stop the leakage, measure from the reference mark to the center of the clamp to see if the clamp is properly positioned over the break or damaged area. Loosen the nuts and reposition the clamp if necessary. If you're going to do that and you've thrown torque into the stainless steel, because everything more likely out here is going to be a stainless steel bolt, I would suggest throwing a little bit of lubricant on that stainless steel stud, because you're going to have friction and it eats the stainless steel. Any kind of lubrication on that will help prevention of any kind of galling that might happen. And of course, recheck tightness and torque the nuts as evenly as possible to the manufacturer's recommended values. And that's it. That's what it looks like at the end of the day. All common, all done. So important tips to remember with your clamps installation: drill a small hole at each crack end to prevent crack propagation. Always clean the pipe as thoroughly as possible. Place reference marks for centering the clamp. Always use suitable lubricant for potable water. I've seen dish soap used, probably not too tasty. I've also seen peanut butter used on repair clamp gaskets as lubricant. Whatever floats your boat, just make sure it's safe for water. Leave sufficient pressure on the line to prevent contaminants entering the line. Loosely assemble alongside the damaged area if possible. Allowing water level to rise above the pipe will minimize the spray, but that might get into some safety issues. And completely tighten centermost bolt to just get yourself started when you're sliding over a live leak. For brakes with minor deflection, a 10-inch or longer clamp with multiple section lugs is recommended. So brakes with greater misalignment should be repaired using two couplings if possible. And remember your gaps. If you're going to use a repair clamp for 4 inches or less, 1/16. For 4 inches, 4 to 10, 1/4 inch, and for pipe sizes, 12-inch or greater, 1/2 inch max gap. When a gap between the pipe exceeds 1 inch, utilize a short section of pipe or a thin strip of metal between the gap and to properly support the repair clamp gasket. Regardless of manufacturer, the repair clamp's working pressure is dependent on the factors. This happens quite a bit. There's a lot of, we're in a mountainous terrain in British Columbia. I get the question quite often. I've got a line that's working at 150, 200 PSI, and it's 16 or 24 inches. And you're in trouble at that point because most repair clamps aren't going to be rated to that high. So these are the factors we're going to ask. If you say, can this repair clamp handle the pressure? We're going to say, what's the pipe type? Next thing we're going to say is, what's the repair? What are we fixing? Is it pitted? Is it a crack? What are we fixing? Pipe diameter is huge. It's one of the biggest factors. And pipe condition. How old is it? And the installation of workmanship is also important too. So in general, and this is most manufacturers, as we go up in area or size, our pressure rating goes down because the gasket area increases and we just can't get the same compression that we can on a 2-inch pipe. So as we can get up, you can imagine to 30, 36, or 48, the amount of compression is negligible compared to what we get in the smaller sizes. You can address these if you have an area in your system that's got high pressures and large diameters. There are repair clamps available that are just heavy duty. You're typically made from plate, and they can work. We've made repair clamps up to 48 inches for 200 and 150 PSI. That's a high pressure for a repair clamp, but they are available in those pressure ratings. So at a bit of time here, I'll try to go as fast as I can, but the one thing with the company I'm with now is we actually can modify existing clamps of smaller sizes or widths and modify them so you can address a longer repair or a larger diameter repair. Improvising wider, so in this particular case, we can improvise wider full circle clamps, improvising larger OD full circle clamps. Always check with your repair clamp manufacturer if this can be done with them, because they can't. Not everybody can. The gaskets are mostly custom in some cases. In that case, they cannot do that. So as with it, we clean the pipe. In this particular case, we're going to have to go wider. I've only got 12-inch wide clamps, and let's pretend that this repair is 36 inches. We measure it. Again, we want to make sure we have enough gasket on either side of it, 3 to 4 inches beyond each side of the repair. So what we're going to do is we're going to remove the gasket from the repair clamps that you have once your manufacturer says it's okay, and we're going to put the gasket back in the shell. This gasket be put in the shell and held in place, whatever you want. Take some tape and fold it over, have some glue, what have you. The glue in the shell does not form the seal. The gasket forms the seal. The glue just holds the gasket in place until we tighten it. So in this particular case, we're going to offset the gasket by 1 inch, and we're going to make sure that that armor plate is within, if it's less than 350, 3/8. If it's over 350 a diameter, it's going to be 3/4 inch recessed in. Now that that's moved over, we're going to do that with 3 other clamps, and we're going to slide the clamps where we've moved it over and overlap the gasket that's now exposed on the opposite side. Tuck the gasket flaps in place and mesh the lug fingers. Engage the centermost bolt and drop lugs and tighten finger tight. If you don't have the drop-in bolts with the finger lug mesh, will still work with this. Push the clamps together so that the overlapping gasket is inserted fully into the adjacent clamp. Pipe surface must be wetted or lubricated. Check to ensure the damaged area is fully covered using the reference marks as a guide. Rotate the clamps the opposite of the gasket flap to ensure the proper seating of the gasket. And what we want to do is stagger the lug sections so that we don't have the lug sections running across the path. We want to stagger them so that the leak path doesn't have an easy path to follow. And tighten the nuts working from the center outward. Tighten the centermost nuts will usually stop. So we're going to basically just work from the inside and work our way out and tighten it up just like it was one clamp, okay? So in this particular case, we've been able to modify, let's say those are 12-inch wide. We can go up to 36 inches, but all we're doing is extending out the gasket 1 inch from one side and leaving bare metal on the inside, and then taking that next clamp gasket and inserting in there. And then once that shell gets to wrap around it, again, the glue's not forming the seal. The glue holds it in place. It's the gasket shell that's forming the compression on that makes the seal. And our torque recommendations, I'm just going through it. So here, we're going to do the same thing, and I know we're running out of time here. If we have, and I've done this actually quite a bit. We did this with the refineries here in Burnaby just very recently. They had an emergency break, and they had a larger OD, so we sent out a bunch of smaller clamps to fit a larger OD, and they needed it right now. So now we got to measure the OD. Remember the pie tape? Make sure you got your pie tape. I'm going to ask you what your OD is, and I'm going to say, oh, it's kind of this, or it's kind of that. Well, I kind of don't know what you're talking about. You kind of got to get me the actual OD, okay? So you get me the OD, then we can make a solution for you. Obviously, again, we're going to mark where the clamp is going. Select 2 or 3 clamps of sizes where their combined OD range is equal to correct OD range of fit for the damaged pipe. So example, we have 20-inch cast iron, which is 2160. We're going to use 3 clamps, 3 clamps. Each 6-inch repair clamp has a range of 684 to 724. This is the extent of my math. Doesn't go any further than this. We're going to add 3 of these together. That gives me a range of 2052 to 2172. I'm going to land right in the middle of that 2160. I now can put 3 of these together that I have sitting on my shelf, and I could fit a 20-inch cast iron or ductile iron pipe, RC900. It is not necessary to use the clamps of the same size. So in other words, I could do a 6-inch, an 8-inch, and a 4-inch. Whatever that math is, it's not critical except for one part, which I'll cover here very shortly. So this bridge plate, so now when you get your when you take a look and you go back to your stores and you see that 6-inch repair clamp sitting on the shelf, it's got the bridge plate or the armor. This armor has a radius rolled into it from the factory to fit that OD pipe it's meant for. This bridge plate molded into the gasket must be flattened. So most manufacturers have that bridge plate or armor sent vulcanized in there, so it's not going to come out. Some of them are glued in with a lesser quality glue, and it may come out, and that might make it challenging for some manufacturers. So what you're going to do is you're going to take that bridge plate, and you're going to get your dead blow, and you're going to take a 2x4, and you're just going to whack it across the bridge plate to flatten out that radius so it sits flat against the pipe. It's not hard to do. I've done it many times, and I know most utility operators on this presentation have modified enough stuff to make it work and do it as well. Once you've flattened it out to the radius of the pipe, it's very simple. Now you're just going to combine the sections of pipe together, and you're just going to start tightening the sections together just like you would a 2-piece or 3-piece. And you're going to make sure the gasket flap is out. And yeah, make sure you use, it's covering the, and use a lubricant in this particular case because you're going to have a lot of gasket area here. So rotate the clamp opposite of the gasket flap to assure proper seating for the gasket and the position of the bolts for convenient tightening. And again, it's just simply tightening from the inside to the out. And again, make sure we've tightened it to sufficiently stop the leakage. Measure the reference marks to make sure you're over the repair. Loosen the nuts and reposition the clamp if you have to. The last thing that I see in a limited basis used in Western Canada is the bell joint lead clamp. And I only say this because some of the older utilities, Burnaby, certainly Vancouver, Surrey, some of the older places that have the old cast iron joints, it's not uncommon to have the joint shift on you and you're going to have it leaking out of the bell spigot. That doesn't mean you have to take the pipe out and cut it out. There are options, and that's called the bell joint lead clamp. Sometimes a hole is open at the location of a leaking pipe and there's no full break or hole or crack. This could be an instance where the pipe's bell and spigot have deflected excessively, or if older pipe, the lead oakum joints have failed. In this case, a repair can still be had, but the choice changes to a bell joint lead clamp. And essentially all we're going to do is give you a clamping mechanism that goes over the male-female section of the pipe, and then we're going to basically just compress a gasket into that opening where the spigot goes into a bell. And that's it right there. And most manufacturers have these available and ready to go, but it's a great alternative than having to you can't put a repair clamp here. It's not going to happen. And you certainly may not want to cut the pipe section out. These are an option too. And that's it. So I thank you for your time today. If I can answer any questions, I'm with USC West. So right now I think we're going to have, is there any questions, I guess? Okay.
Thanks, everyone. Thanks for the presentation. So one other question was, can you use a clamp for a circumference crack?
I'm sorry, can you use a clamp for a full circumference crack? Yes, so that would be referenced to what I'd call like a shear break. Yes. The challenge with that is if you, the chances are is that pipe is either falling or heaving, and or it's been point loaded, is the alignment. So if the pipe is not in alignment, you'll have a challenge getting that clamp on. If the pipe has not moved to any kind of degree vertically, you should be able to use a repair clamp on there. Again, go as wide as you can, but you should be able to do it. The challenge will come is that if the gaps are in there, remember I brought up in the presentation, you need a way to mitigate that gap so the repair clamp gasket can seal properly. But contact me, I can go through that in further detail.
Okay, so next question. For a full break repair clamp, is this a temporary or a permanent repair?
That's a great question. I can tell you what the courts think. It's not a permanent repair because from a manufacturer's point of view, I have stopped the water. I don't stop the deterioration or the integrity of the pipe. So if you're putting it onto some pitted or corrosion and there's been nothing done to address the corrosion that might be present, or if there's whatever unstable soils that are causing the pipe to fail, the repair clamp does not stop that. So I would strongly suggest you contact your manufacturer and ask them that question personally to have clarification on that point, because I have personally been involved in instances where you've had future failures of the same area of repair, and you want to address these issues before you get to that point, because it just becomes a very gray area for both the manufacturer and the utility. And just a proper assessment needs to be done of the pipe to identify if this is going to be a future issue, not only for the utility, but for your water users.
So what you're saying is it's almost more of a risk management
Absolutely.
question?
Absolutely. And I have faith in most utilities and their operators that they know. They know.
Okay. And then the last question that we had online, it's around lubricating the clamp. So what do you use to lubricate the inside of the clamp? And do you have to lubricate the inside of the clamp?
Yeah, absolutely you do. The repair clamp, if you think about all the things, those of us in the waterworks industry, think of any other fitting where you have that much gasket. There's no other fitting you have where you have that much gasket exposed. So now we've got friction, and now we're asking, well, how many rows of bolts to compress all of that gasket area? So gasket lubricant is strongly suggested. What can you use? There's most of your wholesalers are going to have a suitable lubricant. I do not recommend grease, pipe grease, only because I have yet to see a grease tub that is not full of grit. I do not want grit going onto my gasket. I want it to be basically virgin material. There's some spray lubricants. Most the utilities I see, they usually have the spray bottle of dish soap and water. I can't say that's NSF61 approved, but I think in the concentration, I don't know what effect it would have. But I have seen literally peanut butter used and smeared in there too. Anything that's going to be NSF61 quality and just promote. We think that gasket being static when we tighten it up, which that is not the case. Once we start throwing the heat into it with torque, that gasket is going to want to migrate. You may not be able to physically see it, but I can assure you it is migrating into every crack and crevice of that pipe. And you using a lubricant is only going to aid. And remember the grid pattern I showed you at the beginning, those little squares are acting like suction cups, and with that lubricant, it literally sucks onto the surface of the pipe. That's only going to help you repair.
Okay, thank you.
Great,
Thanks.
wonderful.
Thanks very
Thank
much.
you.
Thanks, everyone.